Hello students, in this video we are going to proceed our next session, that is forces acting on gravity dam. How many forces are there which are actually acting on a gravity dam? In this video we are going to study. These are the list of forces which are acting on a gravity dam. First of all, the major pressure and major force which are acting on gravity dam is water pressure, which lies on the upstream side of this dam, as well as some part of water which can be seeps through the or which can be discharged through the sluice gate which is provided on the downstream side of the dam. From this outlet structure, some small part of a water which are discharged on the downstream side and which is retained or which is stably collected on the downstream side. This part also exerts the force on the dam on the downstream side. This part of a water and pressure we have to calculate. Then we have a weight of a dam, as we had defined the gravity dam, that is it resists all the external forces due to its own self weight. So the weight of a dam is the most important parameter. We have a uplift pressure, pressure due to earthquake, ice pressure, wave pressure, silt pressure, wind pressure, etc. These type of factors, or these are the forces which are acting on a gravity dam. This is the image and this is the diagram which shows all types of forces which are acting on a gravity dam. Firstly, just analyze the section of a dam which is represented by A, B, C, D, E and F. You can see this A, A, B, C, D, E, F. This is the cross section and this is the body of a dam. Uh, in a typical cross section of a gravity dam, we had discussed that the gravity dam, it is in a straight plan also, or sometimes it is in a partly vertical and partly inclined shape also. So in this diagram or in this image, you can see the section is partly vertical and section is a partly inclined. Then we have here you can see there is a drainage gallery. This is a gallery which is used to which the purpose of this gallery is to discharge and is to uh, out outflow the, or which gives the outflow for the seep water which is collected under the foundation of a dam. Sometimes what happens, through the cracks, through the pores, the amount of a water is collected and it seeps under the base of the dam and under the foundation of the dam, and this water pressure exerts the force on the gravity dam in the upward manner, which is known as the uplift pressure and uplift force, which the water which seeps through the various cracks, which seeps through the any pores and joints also. See, the construction of the gravity dam, it is not possible, it is not possible to take in a one length itself. We have to divide this gravity dam in a various section and we have to give the various joints in between them. So through the joints, through the fissures, through the pores, through the cracks, the amount of the water will get seeps into the body of the dam, and this pressure exerts the force in upward direction. You can see the arrow is in a upward direction. So to remove this water, this gallery will be provided in the body of the dam. Sometimes it is provided and on the downstream side of the dam. So this is the pressure. Then you can see in the upstream side, first major force is the water pressure, water pressure, which exerts this pressure horizontally on the body of the dam. See, as the dam is constructed for storing the water in a maximum amount, so this reservoir is constructed to store the maximum amount of a water. So this water pressure continuously exerts the pressure on the upstream side of the dam. So to calculate this pressure and to calculate or to remain to keep this gravity dam in a safe mode, we have to calculate or we have to analyze this water pressure in first zone only. So this water pressure, which is having a atmospheric pressure on the surface area, hence the pressure at the surface area is zero. And again, as the pressure intensity increases, it increases towards the base, so its width is equal to the gamma h. Gamma means unit weight of a water into height of a water. So simply by analyzing this triangular section, we can find out the force or pressure of a water force. So again, you can see the next diagram is a silt pressure diagram. So as we are discussed in a reservoir sedimentation, the particles of a silt, the amount of the silt will be carried along with the flow of a water through the various sources, and this silt particle will get collected on the upstream side of the dam. So you can see here this amount of a water also. See, the silt particle, it is not absolutely in a solid form, it is in a semi liquid form, it contains the water also. So submerged unit weight of a silt exerted the pressure on the upstream side of the water. Though this pressure is a small and it is in a too small amount, but we have to consider this silt pressure for the safety purpose of a gravity dam. So for the calculation, again for this, the height of a deposited silt will be given. So according to the height of this deposited silt, we can easily find out the pressure of a silt. It is also exerted is in a horizontal manner. It acts or it exerts the pressure at the 1/3 of a height of this silt, amount of a silt height. Even the water pressure also exerts the pressure at the 1/3 of a height of a water, which is in a upstream side. Again, you can see here the third diagram will be a hydrodynamic pressure diagram. See, it is a very important pressure which is considered and which is categorized under earthquake pressure. Earthquake, it gives acceleration in a horizontal as well as in a vertical manner. When it gives the acceleration in horizontal manner, it exerts the pressure along with the water as well as with the body of the and with the sulfate of the dam, which is called as the inertia force. So when this force exerts the pressure along with the water in a horizontal manner, it is known as a hydrodynamic. See, dynamic means the pressure exerted along with the forces. Kinematic means what? The forces along with the motion only. It does not consider the forces. And static means it keeps it in a rest position. So we have these three phases we had already studied in a fluid mechanics also. So this hydrodynamic pressure we have to take consideration, because this is the most important factor which is categorized under the earthquake pressure. Then you can see here at the above section of this there is a wave pressure. So the upstream side is in the open manner, the surface water is in an open state. So the wind velocity, according to the wind velocity, the wave also created and generated on the surface of this free water level, and this we have to consider this wave pressure also. See, the according to the IS code, the this wave pressure, even the wind velocity, the specified and the standard value will be adopted for the gravity dam as well as for the earthen dam also. So now analyzing all these upstream side forces, uh, we have to consider the self-weight. You can see the portion and the section of this dam is a quite inclined on the upstream side, and it has the slope on the downstream side also. So for calculating the self-weight, simply what we are do, we are just divide this section uh, into a number of sections. That means first one is, see, if I draw the dotted line from the B in the upward, in the vertical downward direction, and I join this dotted line on the base of this dam. So I got the first section, that is a triangular one. Okay, now if I draw the dotted line from the E and in the vertical downward section again, so I got the second section as a rectangular one. If the third part will be the triangular one again. Even also on the upstream side, you can see the particle vertical and particle inclined section is there, and I had told you earlier that if the section is like if the section is in a curve plan also, but we got this pressure, and we have to find out this pressure by the self weight and by the own weight of the dam, not by a curve section, not by a inclined section. So simply what we are do, we are just draw the vertical upward line which coincides with the free surface level of a water. So we got one section, and again if I draw the line, horizontal line from the B section in a horizontal manner, I got two section. First one is a rectangular one on the uppermost side, and second one is a triangular one. So simply I know these are the uh, mathematical section, and I know how to find out the area of these all this section. See, if I want to find out the area for the rectangular, so I can easily use the formula, that is B into D, simply a width into a depth. Then I want to find out the area of a triangle, then I have a formula, that is half into base into height. So simply I put that formula, and I can easily find out the self height of the dam. So this is the major dam. After the water pressure, after finding out the water pressure, we have to find out the self height of the dam. So while finding out the forces, just we know how these forces and how this pressure will be created. Now you can see on the downstream side again, just I had told you that like a water which is accumulated on the upstream side, some part of a water which can be discharged through the sluice gate, it can be collected on the downstream side, and it exerts the pressure on the downstream side section. So it is known as a telewater. So you can see here also, you can get the pressure diagram, and if you remember in fluid mechanics, the pressure, the topic name as a pressure, to find out the pressure we have a devices, that is a manometers, etc., piezometers. But if we want to find out the pressure in a graphical manner, so we have to draw the pressure diagram. So this is the horizontal pressure, the surface area is a horizontal. So we got this diagram, it is in a always in a triangular manner. Why triangular? Because the pressure, atmospheric pressure is zero at the that pressure at the free surface area, the pressure is a atmospheric one, hence the it gives the zero at the free surface level, and it increases at the base with respect to the unit weight of a water and height of a water. So simply by using this formula we can find out the tailwater diagram also. So these are the important factors and important forces which are acting on the gravity dam. So let's proceed. Let's move to the move to our let's move to our first force, that is water pressure. This is a major external force acting on a dam. When upstream face of a dam is vertical, the water pressure acts horizontally. So just in a previous slide, you had seen the section of a gravity dam. First one is a vertical, the upstream side is a vertical, and in the second, the upstream side is a partly vertical and partly inclined. So when it is simply vertical, the water pressure simply acts in a horizontal manner. The intensity of pressure varies triangularly with the zero intensity at a water pressure, since the water pressure is atmospheric one, to a value uh, W, it's small w. See, unit weight is denoted by the gamma and as well as by the small w. So gamma h at any depth h below the water surface. When upstream phase is partly vertical and partly, just we had seen in an image and in the diagram, partly inclined, the resultant water pressure can be resolved into a two component. One is the horizontal as well as in a vertical manner. So to find out the horizontal component, so we have to use for the formula, that is half into gamma into h square. Gamma is unit weight of a water, h is the height of a water on the upstream side. If we want to find out this horizontal component on the uh, downstream side also, so the h, small h dash, is nothing but the height of a tell water. And the vertical component, it can be find out by due to the weight of a water supported by the inclined face. So this vertical component can be find out by the weight of a water. It is equal to the weight of a water contained by column. See, as in this diagram, it is contained by the column A dash, C dash, and B. This part, content of this part can be termed as a vertical component of a water pressure. And it is acting at the CG of the area, center of a gravity of the area, simply. And horizontal pressure, the horizontal component, that is P gamma H, will be acts at a height of a 1/3 of from the base of the dam. So in this manner, we can find out the water pressure. This is the major pressure which is acting on the upstream side. So simply we have a triangularly form a pressure diagram. So the triangularly form means we have a triangular section. So we can apply the triangle area formula and we can find out the water pressure in a horizontal manner. Okay. And when the this upstream side is partly vertical, partly inclined, so this section is submerged in the water. In this section, this a dash, c dash, and b section, the water will be exerted its pressure continuously on this section. So hence this section is again divided into two component. Simply or firstly, we had found out the horizontal pressure according to this triangular pressure diagram, and in second manner we have to find out the vertical component, which can be just I told you that we have to distribute this and we have to divide this section into a two mathematical section. That is one is if this form as a triangular and sometimes it forms a rectangular. So by using the area formula we can easily find out the this section's pressure. Similarly, just I told you that some part of a water will remains and retain on the downstream side also. Similarly, this pressure, this water again exerts the pressure on the downstream side. So again we have to resolve this into a horizontal and vertical manner, and again same formula, by using the same formula, that is horizontal pressure P gamma H bar is equal to gamma 1 upon or half into base into height. So half is base is the gamma H dash, and into H dash. H dash is nothing but a height of a water. And vertical pressure, again the it is equal to the weight of a water contained by column F, F dash and E dash. So this is the water pressure, the important pressure and important force which are acting on the gravity dam. Now next is the uplift pressure. See, just after application of this water pressure, so just I told you that when there is a crack and when there is a joint of a dam is there, so through this pores and through these cracks, the amount of a water will exerted and seeps into the water under the base of the dam and under the foundation of the dam. So the water has tendency to seep through these pores and fissures of a foundation material. It also seeps through the joints between the body of the dam and its foundation at the base, and through the pores of the material in the body of the dam. See, the seeping water exerts pressure, and it must be accounted for in the stability calculation. So uplift pressure can be defined as the uh, upward pressure of a dam as it flows or seeps through the body of the dam or its foundation. So we can define this uplift pressure as it is the upward pressure of a water which is seeps into the foundation or base of the dam. A portion of a weight of a dam will be supported on the upward pressure of a dam or upward pressure of a water. Hence, net foundation reaction due to vertical force will reduce. So, according to the USBR recommendation, the USBR suggests adoption of a uplift pressure intensities equal to the hydrostatic pressure of a water at toe and hill joined by a straight line in between. Sometimes the drainage galleries are also provided in the body of the dam, which releases the uplift pressure built up under it. So, the magnitude of this uplift pressure recommended at the face of the gallery, it is equal to the hydrostatic pressure at the toe plus one third difference of hydrostatic pressure at the hill and toe. So we have the formula when we want to find out the uplift pressure at the hill, as you had seen the diagram of a gravity dam. So at the hill, the uplift pressure is gamma into H. H is nothing but the height of a water on the upstream side. And when we want to find out the uplift pressure at the toe, so the formula and the uplift pressure will be gamma into H dash. H dash is nothing but the height of a water. And if there is a gallery in between the body of the dam, then the uplift pressure will be gamma in the bracket H dash plus one third of H minus H dash. So, see, this is according to the USBR recommendation. Terzagis and Levi-Baskis, the propagators of a second school of thought, recommend that the effective area may be taken approximately equal to the total area when for finding out the uplift pressure. The present practice in the design is to follow USBR recommendation. According to this recommendation only, we can find out the uplift pressure. We have an Indian standard recommendation also. For this uplift pressure, we are using the IS 7894-1975 IS code. See, according to this standard, there are two constituents element in uplift pressure. The area factor, or it is also called as a percentage of a area on which uplift acts, and the intensity factors, it is also called as a ratio which the actual intensity of uplift pressure bears to the intensity gradient extending from head water to the tail water at various points. So there are a criteria of a design of this uplift pressure also. See, according to this, no reduction in uplift is assumed at downstream toe of spillways on account of reduced water surface elevation that may be expected immediately downstream of the structure. It is assumed that uplift pressure are not affected by the earthquake. So for finding out this, we have to assume, or we have to take some criterias, and the uplift shall be assumed to act over 100% of a area. So these are some criterias. By following these criteria, we can easily find out, or we can easily calculate the uplift pressure. So like a water pressure, this pressure is also important. If we neglect this pressure, so in a small period and in upcoming years, the gravity dam will fail definitely. So we have to consider these forces, and we have to calculate these forces. Thanks for watching this video.